Alright guys, Stephen here, and what I'm going to look at this time is using Netmiko to push rendered Jinja templates to devices. Okay, so previously we had looked at YAML and Jinja 2 and how Jinja 2 could call in values from a YAML file in order to create a device specific configuration. Then in the last video we looked at using Netmiko in order to send show commands to a device and return the output to us. Now it's time just to take it one step further, and we'll actually push configurations to a device, and by the end of this we'll take this topology from the point where it only has SSH access and IP addresses for reachability to the point where it's basic but functional. So we'll have EIGRP running on the core and distribution switches. The access switches won't be running EIGRP. All our trunk links will be configured, and we'll have allowed specific VLANs that we create using Netmiko allowed on those trunk links. Okay, now what I'd like to do is just quickly recap what what Jinja 2 does. Okay, so Jinja 2 essentially takes a YAML file and merges it with common syntax that you essentially create. Okay, so if we look at this topology or topology.j2 file, we can see hostname and then in double curly braces the word hostname, and then the double curly braces are closed off. Well, what Jinja does is it essentially references a YAML file and it pulls in values where it sees these placeholders. Okay, so Python will loop over every device that's in this topology.yaml file. Okay, and for example, for core 1, Jinja will render this line with the value for the hostname key under the core 1 subsection. So core 1, hostname, core 1. Okay, if we go down and we look at int double curly braces management underscore interface close double curly braces, we'll see that Jinja will render that placeholder with the value of this management underscore interface key. Alright, now what that ultimately results in is something like this. Okay, so we get a specific configuration for each device. Okay, but what I want to point out is, first of all, as we covered off previously, you can use Python logic in Jinja templates. So here's a little logical OR statement. So if layer this is equal to core or layer is equal to distro here, then that will yield a true or a 1 if you're speaking in binary terms. In the event that this entire statement yields a 1, which will be the case if either one of these is true, then apply this. In the event that layer is equal to access, that will yield a 0 or a false, and this won't be executed. So on the access switches, they won't be sent this EIGRP configuration, and you'll see that if we go down to the bottom there. So we've got access 4 here. There is no EIGRP configuration going to this because the result of this logical OR is a 0, and therefore this isn't executed. The other thing I want to point out is that a rendered Jinja template produces one continuous string of text. Okay, now it just so happens that I've pretty printed this, so this shows escape characters. So \n is anywhere where a new line should appear. So hostname core 1 new line, well, that's correct. So hostname, after that new line takes us to here. In this place, new line takes us to here. Now it so happens that when we send this to Netmiko or devices through Netmiko, this \n is the equivalent of hitting the enter key. So it will take these commands, but if you send one long continuous string, it will only get part way through the list of commands before it times out. Okay, so what we need to do is we essentially need to take this from the point where this is one long continuous string of text to the point where we create individual lines and we get rid of these, because anywhere where you only see \n and nothing else, it's essentially a blank entry. You're sending unnecessary data to the device, and that increases your chance of timeouts as well. Okay, but we'll look at that. Now, in terms of the script, I'll just talk through it line by line like I did previously, and don't be put off by it. Again, a lot of this is comments, just so that as I run through this, I know exactly what's going on, and hopefully it won't be lost for words. So the first thing is your imports. So whenever I'm sending configurations to devices with Netmiko, I import the Netmiko timeout exception handler. Netmiko is an amazing tool. It is the first tool that I properly looked into in a network automation context, and therefore I'll always look on it fondly. But the issue is, it's not the quickest, it is prone to timeouts, and that's especially true at the first point at which you connect to a device. SSH is secure, but it's secure because a series of conditions have to be met before the SSH connection will be completely successful. Those conditions being met requires a bit of negotiation. Negotiation takes time, and that ultimately can sometimes lead to Netmiko timing out. And if I don't import this Netmiko timeout exception, at the point at which it times out, the entire script will throw an error. But if I do import this Netmiko timeout exception, at the bottom of the script I'll show you a little string of text will appear. It will say a timeout occurred whilst I was connected to, then specify the device, but it will continue. The next part of the script will still continue to be executed. Next import is Jinja 2. Specifically, I want to use the file system loader and environment parts of Jinja 2, so I import them. And then from Netmiko, just like before, we import connect handler, and then finally we import YAML, because we are going to be working with YAML files. The next two parts of it should be really familiar with you by now. So I open two YAML files. One will hold the connection details that Netmiko requires, and the other is going to hold the topology. So it's going to hold all of this information. Okay, now something that I do want to point out is that if you noticed that in here I've got all devices followed by, and at the next level I've got core 1, core 2, distro 1, distro 2. In here I've got all devices, core 1, core 2. It's only at levels beyond that where any differences occur. Now the reason that the initial structure, okay, for those first two levels is the same is it means that I can cross-reference. Okay, so I can use the value of a key in the targets file to look up values within the topology file. That's just the way I do it. It makes things easier for me. Everybody's different. There isn't really a wrong way to do something like this, but that's the way that I do it, and I thought it was worth pointing out. Now, in terms of storing our topology.yaml config, okay, what I've done here is I've created a variable, okay, called topology_data, i.e. this is the actual information that is going to be rendered to the Jinja template. And what I've said is that go to the configuration file, okay, which is the result of opening the topology.yaml file and putting it in a variable called configuration, okay, but within configuration, go to the all devices key, okay, so configuration is this, all devices is from this point on. Now, it might not be immediately apparent why I use this, why I specify a jump off point, okay, why not just go in here and not have this all devices key and have the top level just be the devices? Well, what if I don't want to run the script on all devices? So at the bottom you'll see here that I've got, at the same level as all devices, I've got entries called core, distro and access. Now what that means is that if I only want to run the script on the access layer, for example, then it takes minimal change, okay? It takes minimal change into the script to actually make that happen, okay? But the trade-off is that when I do want to specify that I want to run all devices, I have to specify here. But for the purposes of this video, just know that the topology underscore data variable contains configuration and the all devices key. So configuration is the topology.yaml file, all devices is everything at this level. Okay. Now, the next thing you have to do is you have to specify some information that Jinja requires. So I'm going to say template underscore dir, that's just a variable name, and then I specify the directory where the template itself is actually stored. Okay, so up here we were specifying the devices within the topology.yaml file that will be templated. Okay, here is where we specify the directory where the template itself is stored, not the path all the way to the file, just to the directory. Okay, we then set some environment kind of parameters, i.e. I want to use file system loader, which we imported up here. It's part of the Jinja 2 library, and I pass it in template.dir. So essentially what this is saying is load the contents of the file system at this location. Okay, and then trim blocks true and lstrip blocks is true. Okay, now in order to do this, what I've done is I've split it into two distinct functions. The reason for that is that I was looking to learn how to use functions and so on and so forth, but also it essentially makes troubleshooting if something goes wrong a little bit easier. So if I run this script and the configurations go to the devices but the configurations aren't right, I know that chances are the issue is in here somewhere. If I get an issue and the device can't be connected to, I know that the issue is in here somewhere. But first things first, this function is called make underscore template, and I start off with a loop because I want to loop through every device in here. Okay, and this is where having common syntax, a common naming strategy starts to come to the fore. Okay, so what I can say is for device config and targets all devices. Okay, so again we're using the .items key, so we're going to unpack the contents of the targets all devices key. Now we know targets relates to the targets.yaml file, so all devices, we're unpacking these. Okay, at the first iteration over this loop, device is going to be equal to core and config is going to be equal to this, just like it was when we were sending show commands. Okay, exactly the same. Now what we then do is we print the string rendering template. We'll insert device, which at the first iteration is going to hold a string saying core1. We'll use the .upper method to convert it to uppercase, and we'll pad it out either side again with some hashtags. Now then create a template, okay, or a variable rather. Now that variable is called base template. Okay, so its contents are the result of using template underscore env. So we can say here, so this says use these settings, okay, against the get template method, okay, to load topology.j2. Okay, so in here with template underscore env, we've specified file system loader and the template directory. So this line is going to go to this directory. It's going to get the template named topology.j2, which is this. Okay, now I've then created another variable which is going to say is called render, and ultimately it's the result of taking the base template, okay, which by this point is essentially this. Okay, use the .render method, okay, which is the method that allows us to switch out values, and we're going to go to topology underscore data device. Okay, now this is a variable, so for the first iteration of the loop, this will be switched out for the string core1, and this is where cross-referencing comes into it. Okay, so I can see here that topology.data is this, okay, i.e. topology.data is the configuration variable, all devices. Okay, configuration variable is the result of opening the topology file, or the topology.yaml file. Okay, but in the first instance, device is coming from the targets file, okay, which is this. So because I've named the devices the same in both files, when I take this value from the targets.yaml file and then insert it into here to look up in the topology.data or topology_data variable, because the naming is the same, it yields a result. So essentially what's going to happen here is it's going to create a variable called render. It will be the result of taking the base template, okay, which is this. It will then render the base template with the contents of the topology data, topology_data variable, look up the key named core1 for the first iteration, and as it so happens, core1 also appears in the topology.yaml file, and here's the information that's going to be used to render it. Okay, now what I then need to do, as I say, is I need to address the fact that when you render a Jinja template, or a rendered Jinja template results in a string, okay, now that can, as I say, cause issues, as strings can be sent to Netmiko, but they will cause timeouts for long inputs. So you can take a string, okay, and you can use the .splitlines method on it. Now splitlines is built into Python, there's no importing required for it, it's just a Python method. But what it does here is, this has been pretty printed, okay, so essentially this shows what Python sees, if you want to think on it that way. And anywhere where Python sees /n, it's going to insert a new line, okay, so it will say hostname core1 new line, okay, so it'll be a separate line and a separate string, okay. But the issue is that here we can see \n on its own, and what that ultimately leads to is entries where there's nothing in it, okay. So as splitlines runs through, it will split each of these into its own line. It will create a list where each entry corresponds to this. So the first entry in the list will be this, it will be the next entry will be that, third entry will be this, and so on and so forth. And that list will be called commands, okay. But the issue here is that, look, I've got entries that don't have anything. That's unnecessary input, right? So what I'm going to do is I'm going to say commands is a list, okay, and I'm going to use the .remove method of Python to remove anything that is blank, okay. And a while loop essentially says that whilst there is blank entries in it, continue to remove them. Once there are no blank entries in it, move on, okay. Now the final part on this is that the first function must call the second function. The second function is actually going to connect to the device and send the template, okay, and it has to be called from in here. So I call the function called send template, see how that highlights, okay, and when I'm doing so, I pass it in the device, the configuration, and the commands. So for core1, what's going to be passed in here is device, it's going to be a string, it will say core1. Config is going to be passed in, it's going to be the result of, it's going to be that, okay. Then commands is going to be essentially this, okay, but it will be broken down into a list with all the blank lines removed. Alright, now when we then go into the next function, we have to accept those arguments in. So you can see it's reflected here. So we pass device, device appears, config, and the same for commands. And what this is going to do, it's going to first of all print the line again, connecting to device for the first iteration, that will be core 1 in uppercase, and then pad it out either side with hashtags. And then we've got try except. This is where the Netmiko exception handler comes in. So it's going to say, try to do this, okay? Now, the only reason that you shouldn't, or say to Python, the only reason that you shouldn't complete this, okay, is if you get a Netmiko timeout. And in the event that you do get a Netmiko timeout, please tell me by printing the line timeout exception raised on device.upper. So the name of the device, all in uppercase. Okay. So as this comes in for core 1, first iteration over the loop, it's going to take the device, it will print connecting to core 1 net connect. Again, this is all familiar. It is the result of taking connect handler and passing it config. So for the first iteration of the loop, that will be this. Then we create another variable called send commands. Again, that uses net connect. So it says use the SSH connection, and this is where it's a little bit different for sending configurations. Okay, so we use send underscore config underscore set. That is the Netmiko method that you use to send configuration commands to devices. Okay, now for some reason you can just put the name of commands in here, which is passed in from up here. Okay, commands is a list. Okay, now remember in the previous video where we had a list of commands. It was show a VLAN brief and show IP interface brief, and we had to create a loop, okay, to go over that. For some reason, if you don't use a loop when you're sending show commands, it doesn't work. Okay, it tries to strip things off that aren't there and stuff like that. So you have to use a loop, and that fixes it. But when you're using send underscore config underscore set, you don't need that loop. It just works. You can just plug in the name of the list, which is commands, which is the result of splitting all of this over here into separate lines and stripping out the blanks. Do that for each one of these commands. Okay, then we're going to print sync commands, which is, in the case of sending configurations, just feeds back the CLI input. And the only reason that we won't do that is if we get a timeout exception raised, in which case we'll be told about it. And at the bottom of it, we call the make template. Okay, now again, this can look more complex than it actually is. Okay, but it really isn't all that difficult. Okay, do it once, do it twice. Once you do it a few times, it will become second nature to you. Okay, and this is kind of important, in terms of developing Python skill, for me at least, but B, also once you understand the facilities that Netmiko's got, when you come to use it in Nornir, then again it makes things a little bit easier. Okay, so I'm going to go and I'm going to change to the Netmiko directory, and I'm going to run this, which I believe is called netmiko fs.py. Okay, now I'm going to pause this. I'll let it run for the first few devices. I'm then going to pause it because this is a bit slow, okay, and not the most enjoyable viewing. But I'll let it run through for the first one so that you can see what gets returned and so on and so forth. Then I'll pause it and I'll come back when it's all completed. All right. Okay, so now that that script has run, this is kind of timely, I suppose. So here we can see what I was talking about with Netmiko timing out, especially when you first connect to devices. So at the bottom of this script, I've said essentially try to connect to Netmiko and send the rendered Jinja template. In the event that you get a Netmiko timeout exception, print the line timeout exception raised on, and then the name of the device in uppercase. And if you look here, the first time I ran it, access 5 timed out, and as a result, rather than the script just throwing an error and exiting, it printed the line timeout exception raised on access 5. There was another one where it occurred, I think it was core 2. If we have a wee look, yeah, core 2, so same thing applied. So what I did was I ran the script again, okay, and it all went through just fine, no timeout exceptions anywhere. All the configurations went over. So we can see that all the commands have been sent, but for the avoidance of doubt, what we can do is we can go in and we can have a look and make sure that the correct commands have been sent to the correct devices. So if we go into core or distro 2 and we can see distro 2, so the host name's applied, which is good. If we go in and say show IP proto, we can see EIGRP 1 is running. Okay, if we then say show IP EIGRP neighbors, we can see that we've got 3 neighbors, which is correct. Okay, if we say show VLAN brief, then we can see the VLANs have been applied. These VLANs were created with Jinja 2 templates, but if we go into access 1, for example, and we say, and we see the host names applied, show IP proto, then no EIGRP running there. For the avoidance of doubt, show IP EIGRP neighbors, nothing. Show VLAN, however, show VLAN brief, we can see the VLANs are there. Okay, so that's the basics of it. My best advice on this would be just try it. It's unbelievable when you get it working. There's something really satisfying about seeing configurations scroll up your screen and devices suddenly just working the way that you want them to. And as I've said in previous videos, this is a really good way of getting a lab quickly to the position that you want it in. So when I'm done with this video, I will just restart these devices or switch them, stop them. That means that next time they start up, they won't have any of the configurations that I've pushed to them. And if I then want to do an OSPF lab, I've got another template that pushes basic OSPF configuration to these devices. And I don't have to touch the CLI. Alright, thanks very much.